Now, one method to determine the orders of a reaction uses what's known as the initial rates method. There are other ways, but this is one that will enable us to determine a number of different orders in essentially the same way. The point about this particular method is that the only point that we can actually definitely know the concentrations of the reactants that we cannot monitor is at the very beginning. So that's why it's called an initial rates method, because what you have to do in these cases is do a series of experiments repeating the experiments or runs of the experiment, but changing the initial concentration of one of the reactants only, so that you can compare your first run against another run where you have changed the concentration of one of the reactants, and then you can compare initial rates of reaction. So, for example, if the reaction happens to be zero order, in other words, rate is proportional to, let's say, the concentration of A to the power 0, and you are keeping everything else constant, just varying the concentration of A, then if you double the concentration of A, it will have no effect on the rate of reaction, keeping all other reactants constant. If you treble the concentration of A, then that will have no effect at all. A first order reaction, if it's first order with respect to one of the reactants, let's say A, concentration of A to the power 1, then what we will expect to see is that if we double the concentration of A, keeping all the other reagents constant, then we can expect a doubling in the rate of reaction, because the rate is directly proportional to the concentration of A. So if we double the concentration of A, rate doubles. And if we treble the concentration of A, of course, rate will also treble. So if we compare again two runs in the experiment where we are keeping the concentrations of all the reagents constant apart from the concentration of A, if it comes out to be a second order reaction, we can expect that if we double the concentration of A between the two runs, the rate is going to increase, or the initial rate is going to increase by a factor of 4. And if we treble the concentration of A, then the rate is going to increase by a factor of 3 squared, 9.